My name is Rahil, and I'm the pre-sales consultant. I'm working at Redington Gulf, and I handle basically AWS, and I help partner in architecting the overall solution on AWS. So in today's webinar, we're going to discuss about web application security, which is a very important aspect of when you deploy any application on AWS. So security is really, really important. And believe me, web application security is completely different from infrastructure security. So we will have a deep dive session in web app security, and we'll understand what are the services available for us, which we can use in AWS, what type of attacks we can get, what are the most common attack vectors. So we'll address those points in the upcoming session, in the upcoming slides. All right. So what to expect in this webinar? So in this webinar, we'll define what type of attacks you can get. We'll have an overview of different application security vectors, and we'll also discuss about building security in your application, which is very important. So security starts from your application, and you have to ensure that your application is secure. So we'll talk about building security in your application. Then we'll go and talk about building security around your application. So once your application is already secure, how we can build security around your application to make it even more secure and make it, so that nobody can penetrate inside your application. We'll discuss about some of the advanced mitigation strategies. So this is the agenda for today's webinar. So let's talk about defense in depth definitions. How we can address what do we mean by defense in depth? So defense in depth, it means we follow multi layer architecture. So we create multiple independent layers of security around our application, of course. What is the advantage of creating those layers? Well, it slows down the attack. So if we have only single layer protecting our application, we are highly vulnerable. So once an attacker uh, enters or breaches that layer of security, we are exposed, right? Our application is exposed. So it's always better to have multiple layers of security, which is independent actually, and which operates on its own. So one layer do not have any dependency on the other layer. Sometimes it's called onion architecture because there are multiple layers involved here. So advantage, as you can see, it decreases momentum and effectiveness of an attack, right? Because penetrating multiple layers of defense is not easy. Second thing, it requires an attacker to break multiple progressive specialized layers of defense. So there will be specialized layer of defense. So attacker have to have a very versatile skill set in order to penetrate all those layers. The effort required to mount a successful attacks become increasingly difficult, and there is a cost for an attack. So when you make an attack, there is a cost. So the more time you spend, the more cost you're gonna incur. So it becomes extremely difficult for the attackers. So there will be a point when the attacker will give up and say, okay, there are so many layers we can't get in, so the attack will be unsuccessful. So multi-layer defense is highly recommended. Now we'll talk about platform, defense in depth strategy for the platform. What is there in building a secure platform? Then we'll talk about building security in your application, and then we'll talk about building security around your application, right? So let's talk about platform. So in your application, building security in your application, that completely boils down to your application, and around your application is your application architecture, right? So we'll discuss this in upcoming slides. But first and foremost, very important to understand layer architectures. This is basically OSI model. If you can see, there are 7 layers: physical layer, data link layer, network layer, transport layer, session, presentation, and application layer. So in AWS, we don't have to worry about physical layer and data link layer because it's managed by AWS, right? So you don't have to worry about physical network security, a physical layer and data link layer. There are tools available, there are services available to secure network layer, transport layer, and there are services available to secure session, presentation, and application layer. So basically, when we talk about application layer, we have CloudFront, we have elastic load balancing, we have Route 53, publicly hosted zones can sit in Route 53. When we talk about network layer, transport layer, we have Route 53 with private hosted domain. We have EC2 instances which can be deployed in auto-scaling group to absorb the attacks. And we have VPC, which gives us complete control on our privately owned CIDR, right? What types of attack we can get at different layer? So in application layer, presentation layer, and session layer, common attacks are HTTP flood. We can have SSL abuse. So if you have a vulnerability in your SSL certificate, it can be exploited. We have some app exploit. So if you're running your application on a LAMP stack, or some kind of vulnerability is detected in Apache, that can be exploited as well. Bots can attack, bad bots can attack. We can have malformed SSL, SQL injections, crawler. These are the types of attack which can happen in your application layer, presentation layer, and session layer, right? And what about transport layer and network layer? Well, there will be different set of attack which can happen at transport layer and network layer, right? This can be SYNAC flood, UDP flood, reflection, teardrop, ICMP flood, ping of death. So ping of death is a very old way of making an attack where you just ping it till the server stop responding. So this is again some of the common attacks which can happen at transport layer and network layer. And as I said, the physical layer and data link layer is operated by AWS, so we don't have to worry about security of these two layers. It is taken care by AWS. This uh, uh, this reminds me of a shared responsibility model. So AWS does have shared responsibility model where customer is liable to manage certain components, and he needs to manage certain aspect, and AWS will manage certain services and certain uh, roles. Let's find out. So when we talk about AWS managed responsibilities, so this comes down to AWS foundation services such as compute, storage, database, networking, and global infrastructure. So you don't have to worry about, let's say, physical security of your data center, right? You don't have to worry about biometrics. You don't have to worry about cabling and securing the host, virtualization stack. That's out of equation. So this will be taken care by AWS. Now, what we need to manage basically is operating system. Especially when we are going with infrastructure as a service approach, we have to take care of operating system. We have to patch our operating system. We have to set up right network and firewall configuration. So this, if we do it properly, it will prevent most of the network layer and transport layer attack. We're also responsible for securing our platform, our application, and controlling identity and access management, providing access to right set of users. So this also falls under our responsibility, right? Then we have to think about encryption. So encryption, we do have services. We do get services from AWS, but it's on us to enable encryption. So when we talk about encryption, client-side encryption, data encryption, it's on us. Server-side encryption, it's optional but highly recommended. So it's also on customer. Network traffic protection is also on customer. So we do have tools and services which can help us in encrypting our data, but we have to use those tools and we have to encrypt our data, right? So, and of course, whatever content we are writing and whatever application we are deploying on AWS, it's also our responsibility, right? So it's a shared responsibility model. Now, with AWS, we can get standard protection. All internet-facing web applications get AWS Shield Basic. So they will have basic protection against most common attacks, uh, especially the DDoS attacks. So these kind of protection will be there. At least basic level of protection will be there. Customer using Amazon Route 53 and CloudFront have additional application layer mitigation across 200 points of presence. So if you are using Route 53 for as a DNS server, and if you are using CloudFront for application acceleration for caching, then yes, you do have additional application layer mitigation, right? Now let's take a customer example here, Slack.com, which uses Route 53 and CloudFront, you know, to secure API acceleration for caching purposes, and also uh, the static content can be served from CloudFront in this case. So this is the architecture where the Slack they use Route 53, and their zone is hosted on Route 53. Then there's CloudFront layer, which communicates with application load balancer. So application load balancer is uh, uh, and behind application load balancer there is a pool of Amazon EC2 instances, your servers actually. So if you see, CloudFront is placed in front of load balancer, right? And then further, CloudFront, there is an alias to CloudFront DNS, which is an entry in Route 53. In this way, they have uh, the secured API acceleration is done. And CloudFront is, if you know, it's a global service. So my footprints are uh, is expanded. So if an attacker willingly or unwillingly tries to get into your application, we have an additional layer of security at CloudFront, right? And this reduces load onto your EC2 instances as well. Now let's talk about building security in your application. Remember, we discussed about 3 points: in your application, around your application, and some of the advanced mitigation techniques. So we'll first talk about building security in your application, right? So this could be your first layer. So how can we build security in our application? Well, the easy way is to harden security within our application by running some vulnerability assessment tools, vulnerability assessment softwares, and analyze what are the vulnerabilities in our application. You follow the documentation and implement the best practices for your application. Let's say if you have a .NET application, follow the best practices for .NET and then implement your application. Right, and you enable safeguards basically for common attacks and exploitation. So if you have a known if let's say there is a known vulnerability for an application, let's say LAMP stack, then you have to set up a safeguard against those vulnerabilities. But if we follow the best practices for an application, I'm sure it will cover everything, right? And on top of it, we will also do vulnerability assessment. So if anything, any door is left open, so we can easily identify and close it. So when we talk about application, first thing we need to understand what to protect from, what kind of protection do we need. So if we talk about web-based application, yes, we can have a lot of DDoS attack. We can get a lot of cross scripting attack. It is possible. So it's very important to understand what kind of attacks can happen. Then only we can protect against those attacks, right? So first and foremost, very important to understand what to protect from. Then you can proactively architect your application to protect against these vulnerability. So security, as you know, it's a continuous process, right? It's not just one time implement and done. That's not the case, right? So you have to proactively architect your application to protect against these vulnerabilities. And then you should have a mechanism in place to monitor and detect when you need to take action. And most importantly, we should try to automate the security action as much as possible, right? We should have, first of all, there should be a mechanism to detect, and then there should be a mechanism to take action. And those action, I highly recommend that it should be automated. You don't have to, receive an alert and then based on that you have to take action. No, it should be automated as much as possible. So when we talk about app security, there are 10 attack vectors basically. Three of them are very, very common. I'm sure you've heard about injections, you've heard about cross-scripting attacks, and you might have heard about insufficient logging and monitoring, which can lead to a number of attacks. So if you do not have sufficient logging and monitoring mechanism in place, uh, you are vulnerable in that case. So a lot of attacks can happen and you might not even notice that this happened, right? So very common attack is a SQL injection attack. Then you can also have broken authentication attack, sensitive data exposure, XML external entities based attack, broken access control, security misconfiguration, insecure deserialization, using component with known vulnerability. These are like 10 very common attack vectors when we talk about app security, and this is from OWASP, right? So here, the three common attacks that is highlighted here is SQL injection, cross-scripting attack, and insufficient logging and monitoring. So let's talk about SQL injection. So in this example, you can see what is a vulnerable usage. So here we have a string called new name. In the vulnerable usage, you see I'm passing my new name as a query, which is risky, by the way, because the queries can be updated, right? And an attacker can put his own query, and he can put his own malicious uh, uh, entry here in the form of string and try to execute and try to store the malicious entry into your database. So this is a vulnerable usage. Now the secure usage is to pass the string in a function. So let's say set string is a function, and we're passing that string in a function. Now there's no way an attacker can change that string, right? So this is a secure usage. Very important when you talk about security in application, you should consider those factors, and you write your code in such a way that you are protected against SQL injections and other type of common attacks. Now let's talk about cross-scripting attack. I'm sure you have heard of cross-scripting attack, right? So what is it? So cross-scripting attacks allows you to run, let's say, JavaScript code uh, from the client side. JavaScript is a client side. JavaScript code runs at the client side, right? So uh, when we run some malicious code into our website, let's say if you have a form, and if your form allows you to put HTML code, right? Then the attacker can take advantage of this and can execute some malicious script inside your comment box, which you don't want, right? And a very common scenario can be your cookie theft. So your cookies can be stolen, and then when your cookies are stolen, so it can be presented to the server, and server will identify you as an attacker, as a registered user. So that's very dangerous, and we should have mechanism to protect against cross scripting attack. Second type of attack which can happen is website defacement. So uh, you have a very nice, pretty looking website, but you're not protected against cross scripting attack. So an attacker can take advantage and run some malicious code, and they can deface your website. So they can put their own malicious link in your site, which can cause a lot of problem. So this is again one of the common attacks. Now, what is a defense for cross-scripting attack? Uh, Now it's very common, and we have a lot of solution for cross-scripting defense. When we talk about building security in our application, so we can it is highly encouraged to use HTML encoding, right? JavaScript hex encoding. You can also use URL encoding, CSS hex encoding. So you are not actually exposing your full URL, but you are exposing an encoded URL. So it's very hard actually for the attackers to know what encoding scheme you are using, and to make a cross-scripting attack. Then you can also use HTML sanitization. So which is very simple. You don't allow any script to run inside your comment box, right? Comment box is only meant for text. It's not meant to execute script, right? So HTML sanitization is very common. And you can do sandboxing, parsing, serialization. These are some application related tech. techniques which you can use, and you can use safe API basically to protect against XSS defense. Right. So what protective controls we have? We have to define security requirement. Then a common control is to validate all the inputs. So whatever inputs a customer or let's say a user is supplying, you should have functionality to validate it, right? So you just want to make sure that somebody is not submitting an HTML code or a JavaScript code in your form, right? So validate all the inputs. Implement security logging and monitoring. This is again very important. So application logs has to be set up, and whenever such kind of events occur, or even if somebody is trying, so we should it should be logged and it should be monitored. So and then you should always set up error and exception handling. Exception handling is very important aspect of application deployment, and it should be set up properly. The other thing which you can do, these are the four very common proactive controls that you have. The other controls that we have is to leverage security frameworks and libraries. So if you use a web application framework, it'll make your life easy, and you can actually handle exceptions and sessions in a much better way. You can secure your database access, right? You can encode and escape data. Right. This is also possible. You encode the whole data. Implement digital identity. You can enforce access control, protect data everywhere. So you can actually enable encryption on your data. So that's few other techniques which can be very handy in protecting against some of the very common attacks. Right. Now let's talk about building security around our application. We have secured our application, but how to secure uh, how to build a secure environment around our application, we'll discuss in this module, right? So this actually boils down to our application architecture. How do we architect our application? We have a secure application. Now it has to be architected properly, right? So uh, here the most important thing is protection against vulnerabilities in third party software. So you should have protection against common vulnerability. If you're using any third-party software, you should always refer to the known issues and known vulnerability, and you should uh, implement those hot fixes. Protection against common attacks and exploitation. So case study here is very useful. So you should go and check. Again, you can refer to the vendor guide and see what are the common attacks that can happen on this uh, particular stack of application, and then you follow the guide to implement the safeguards. Protection against application specific attacks and exploitations also, this is again very important aspect. And uh, best practices we discussed has to be followed. We have to follow the best practices from the vendor, and harden your security within your application, which we already discussed in our previous module, how we can how we can build security in our application, right? So AWS enables defense in depth. So what are the services that AWS offer? We have standard protection with Shield Basic. We have AWS managed rules, right, where AWS have written rules for protection against some of the common attacks, right? We have custom protection with WAF. We have scaled configuration and audit abilities. So we can actually scale our infrastructure to absorb some of the attack. That's also, those services are also available. Then we have seller managed rules. So AWS has a marketplace where a lot of security vendors are selling their own managed rules. So in this case, you don't have to write your own rules, right? Because uh, your team might not have those experience. Your team might not be experienced enough to write security rules, right? So you can, in that case, go to marketplace and get your own rules. Rules are automatically updated by AWS seller. That's again a good thing. So if there is any known vulnerability which is detected, then the vendor automatically updates the rule, and AWS sellers will update the rules accordingly, and you will always be your rules will always be up to date. And you have choices of protections. You can select what attacks you want to protect from. So whether you want protection against transport layer attack, whether you want protection against layer 7 attacks, so you can pick and choose. So this is seller managed rules. Now AWS also launched AWS managed rules in November 2019, right? Where AWS threat research team actually come up with a set of rules which is curated and maintained by themselves, and they listed down protection against some of the common application attacks, and these are available as managed rules, so we can very well subscribe to those rules. If you have an application, you can subscribe to those rules. It leverages security knowledge and threat intelligence gained from Amazon. So Amazon, as you know, it operates at global scale, and they leverage that security knowledge and threat intelligence, and created a rule for their customers so that they can protect themselves against such common attacks. So both partners and AWS managed rules are now selectable from directly within the console. So you can select it directly from AWS console. You don't have to go anywhere else. And these are, by the way, some of the rules which comes under AWS manage rule set. So you can see you have protection against SQL DB. There are set of rules inside SQL DB. There's a rule set for Linux. There's a rule set for PHP, WordPress, POSIX, AWS IP reputation list. So and description is also given. And by the way, these are not the only rules. There are many other rules. So I've just listed down few of the rules. So let's talk about IP reputation list from threat research team. Uh, so basically, threat analysis automations update the threat database, and it updates the IP address. So if there is an IP, if there is a spam coming from an IP, it will be updated in the threat database, and that database will be leveraged by AWS WAF, and based on that, your attacks can be blocked from that particular IP. So if you're subscribed to that managed rules, then yes, you will be protected against common attacks which happen from those IPs. You also have custom protection with WAF, so you can write your own rule inside AWS WAF, and you can guaranteed protection for your application. So at times it is each application is different, so the security requirement for the application is also different. Sometimes you just want to deny any attack based on geo IPs. Sometimes you just want to deny any attack based on the rate. So if the rate of request is very high, you want to block such attacks. And let's say if the size of the request is very big, you just want to block that attack. So you can actually create your own custom rules with AWS WAF, and this will be this will guarantee you protection against some of the attacks which can happen to your application, right? And this actually integrates very well with API gateway. If you're using API gateway for fronting your application, it integrates very well. It integrates very well with CloudFront, application load balancer, and the logs can be sent to Amazon CloudWatch. So bottom line, it is possible to write our own custom rules for AWS WAF. So custom protection with AWS WAF, as you can see, updated customer-facing APIs for AWS WAFs are available since November 2019. So we have new detection capabilities. OR logic has been added in AWS WAF. By the way, AWS WAF is a service if you don't know. So you can very well use that service for your and you can use it for as a web application firewall. When you subscribe to when you create any rule in the WAF, So you do have a capability to add OR logic, or you can actually do multiple transform, and you can have variable cider ranges also in that particular rule set. There are new ways to write rules. So AWS has made it easy for us to write rules. So JSON format is supported, right? And you can call update web ACL once. So you don't have to manually update your ACLs one by one. You can update all the ACLs together. And elimination of various service limit. These are some feature improvement which is listed here. Now we'll talk about scaled configuration and audit abilities. What if we have multiple AWS accounts? What if your application, let's say, uses component deployed in multiple account? Well, to do that, we have a service from AWS. It's called Firewall Manager, which enforces the rules, the security group rules, or the ingress egress traffic which you allow or deny, which you allow basically. Uh, so those rules can be populated in all the AWS account. So you don't have to manually write one rule, one security group in account A, another security group in account B. It can be centrally managed using AWS Firewall Manager. You have integration with AWS organizations, and Amazon VPC Security Group, WAF, and AWS Shield Advances also supports scale configuration and audit capabilities. You can automatically add protection to new resources. So basically, if we have a new resources, we can automatically uh, guarantee protection to those new resources by following, let's say, landing zone configuration, or by following control towers, which automatically guarantees that AWS best practices will be followed. And you have audit for non-compliance also. So you can use config rule in this case. So config rules can help you in identifying whether your compliance requirement are met or not. And if something is out of compliance, let's say if somebody change a security group rules to allow traffic from anywhere, immediately you can set an alert and you will be notified. Or you can take it further. Let's say if there is a resource which is out of compliance, in this case security group, which allows traffic from anywhere, you can take automated actions using lambda function to remove that rule. So this is also possible. So AWS WAF enables defense in depth, right? So it supports multiple integration points. So WAF can be placed in front of CloudFront, it can be placed in front of API gateway, and it can be placed in front of application load balancers, right? And by the way, if you're using all of these three services, then you can put WAF in front of all these three services. It's possible. So you will have a different set of WAF configuration for CloudFront. You will have different set of WAF configuration for API gateway and for application load balancer. And it supports multiple defense strategies. You will have managed rule, as we discussed, some of the rules written by AWS to protect against common attacks like SQL injection matching. So you can put your managed rules within WAF template and you can use it. You have rate based rules, cross scripting matching, and you have geofencing, dynamic or static matching. And on one more thing I wanted to add here, you can also have your custom rules. So you can create your own custom rules in a WAF configuration. So that's supported. There are multiple approach for WAF. One is multi-layer strategy. So you can have multiple layer of WAF configuration, right? So you can put WAF in front of API gateway, and you can put WAF in front of application load balancer. In this diagram, if you see, we have Shield and we have Route 53. Route 53 will pass on the request to WAF, and WAF will be in front of API gateway, right? And after the API gateway, we have another layer of WAF, which is in front of our application load balancer, right here. And then we have pool of our EC2 instances, and S3 bucket is also there. So the we can the idea here is we can use multi-layer WAF strategy. We can put WAF in front of load balancer also and API gateway also, so protection is guaranteed. And not only API gateway, but we also have CloudFront here, so we can put WAF in front of CloudFront. So of course, there will be different set of rules. When we talk about CloudFront, it requires different set of rules. When we talk about load balancer, it requires different set of rules, right? So we can create those rules based on our requirement. Either we can use managed rules by AWS. Now there is another strategy called multi-stack strategy, and this uses AWS managed rules. So in this case, if you see again, we have WAF, which is in front of CloudFront, and we have WAF in front of two different application stack. One is LAMP stack, Linux, Apache, MySQL, PHP, and the other one is Visa stack, Windows, IIS, SQL Server, and ASP.NET. Right, these are two different applications. And if you see, we have WAF in front of CloudFront and in front of application load balancer for LAMP stack, and in front of application load balancer for a Visa stack. Now here, if we put WAF in front of CloudFront and if we use AWS managed rules, we can use rules for core rule set. We can use rules for IP reputation, because CloudFront, we basically deals with IP. We want to restrict traffic from certain IP. We want to avoid traffic from blacklisted IPs, right? We want to avoid traffic against SQL injection. So these are the rules that I would need probably in my CloudFront configuration, right? Whereas in LAMP stack, I will have different sort of requirement. In LAMP stack, I would need protection against common vulnerability for Linux. So I will subscribe to AWS managed rule for Linux. I would need protection against some of the common exploit with PHP, right? So I will subscribe to AWS managed rule for PHP. And I might have some custom rules requirement. So for that, I will create my own custom rule. When we talk about Windows, we will have different set of we would require different set of rules, right? There will be different set of attacks. So I would need to be protected against some of the common attacks which can happen on Windows OS. So I will subscribe to AWS managed rule for Windows, and then I will write some of my custom rules. There could be some of the exploit for ASP.NET. I want to subscribe for those rules. The idea here is, based on our configuration, based on our stack, we can have different set of managed rule for each WAF configuration, right? So there's no one size fit all. So CloudFront will have different requirement. Your LAMP stack will have different requirement, and your EC2 will have different requirements. So we need to subscribe to different rules in that case, and it's very well supported. So you don't have to put one WAF in front of the whole application, right? So the better approach is to go with multi-stack WAF strategy. Now we'll talk about access control and content-based authentication, right? This is also supported in WAF, by the way. So let's say you have a login page for your website, and this is admin login page. And if you publish anything over the internet, if you have a website and you publish it, automatically by default your admin page will also be published, right? But we can control it through WAF, and we can say that, okay, admin page should be accessible to my admins who are located in Seattle, right? I don't want public users or public internet user to access that admin page, right? So I can very well do that with AWS WAF. How I will do it is by creating a rule. So I will create a rule, to restrict specific URIs, which is my login page, right? So I will write a rule saying that, okay, if my IP is, let's say, this, and this is my public IP where my administrator access the system, right? In that case, you can just allow login, and for all other case, can just deny login. So string match rule you can create in WAF, and if string URL string matches with /admin/login CGI with lowercase transformation, you can allow the traffic only from these particular IP ranges. So it's possible. That's the purpose of WAF, right? We can also, do an inspection and analysis of web request, which is through Kinesis Firehose, CloudWatch. Kinesis Firehose, as you know, right? If you are, streaming your logs, you can do intelligent analysis using Kinesis services. Kinesis Analytics. It can be integrated. I'm not going to go in deep with these technology, but it is possible to analyze and inspect your web request. And let's talk about some of the advanced mitigation strategies. What you can do, and we'll take some customer example. So E-Vitamins, they uses hot honeypot strategy and automated IP blacklist AWS Lambda function for automation. So what we need here is an IP set contains for our list of blocked IP address, then a rule to block request match IP if match IP event is detected in our IP set, and then a web ACL basically, which allows request by default, right? Then we should have a mechanism to detect bad bots. So if any request comes from bad bot, you remember we have that database from AWS Threat Intelligence database. So in this case, we will use that database to detect bad bots, and then we can add mechanism to add bad bot IP address automatically to the IP set, and based on that, we can create a deny rule. So by default, everything will be allowed, but as and when we detect a bad bot, the IP will be updated in IP set, and the deny rule will be created automatically. Automatically, right? You don't have to do anything. So once set up, it will automatically detect the bad IPs, and the request will be blocked. So this is a very effective strategy. It works like that. So initial request, will go through the honeypot URI, right? This, by the way, will not have any of your slash honeypot URL will not have any of your production or any of the critical, resources. So it goes through a set of rules, managed rule. It goes through WAF. The IP will be detected, and based on that, a Lambda function can be triggered to add that IP into our, IP set, and then a deny rule will be applicable for the next subsequent request. So very effective technique. Second technique is, by using IP blacklist with TTL. So here, this can be a bit complicated, but again, if we manage to do it, automatically the IP blacklisting rules will be applicable in our WAF. So here, web request will be passed to Kinesis data firehose, and then Kinesis data analytics will run to detect whether the IP actually matches with the blacklisted IP, which is there in our threat database provided by AWS. And if it is matches, a Lambda function will be executed to store that IP in a DynamoDB table. The IP can be stored in DynamoDB table with time series, right? So we'll put the timestamp also, and then Lambda will pass that request to SQS, and then another Lambda function can be triggered to update the IP set in WAF, and then a deny rule will be applicable. So that can be a bit complicated, but it is again very, very effective, to automatically, create an IP blacklist rule. And then automate security, as we discussed. It's very much possible using AWS Lambda function, WAF, DynamoDB, and guard duty. Guard duty does intelligent log analysis, and will be able to provide much more details about the request. So implement automatic detection, controls, and alert. It's always recommended by AWS. The actions should be automated. So another example, how you can automatically block suspicious host. You have guard duty, which collects log from different sources. Let's say your CloudWatch logs are fed into guard duty. Your CloudTrail logs are fed into guard duty. Logs from other sources are fed into guard duty, and then you have an event finding. You found an event that, okay, particular event is, you is the red flag event, and you pass that event to Lambda function. Then Lambda will automatically, send a notification to you. It can send an SMS notification, an email notification via SNS. It will update the IP address, or the, it can store state data for checking the blocked host. So what is the state before? Was it blocked? Yes or no? And what is the IP address of the host? So if it is not blocked, then a network ACL rule can be updated to deny all traffic from that particular host, and this can be fed to AWS WAF IP set. So in IP set, we can fed that IP, and the traffic will be blocked. So very interesting use cases, how you can automatically block suspicious hosts. But I just wanted to show this because it is possible. Many times I get a question that, security is not automated, you have to take manual action. That's not the case. Basically, we can automate most of the actions. Some of the action, I understand, it has to be done manually, but actions like blocking suspicious hosts, blocking suspicious IP can be automated easily, right? And that's it from my side. So if you have any question, just feel free to drop in the chat box, and we'll answer it one by one.